This is the Focus Applied Technology benchtop dynamometer. Important wiring connections to the dynamometer include the control current from the dynamometer and the output to the dump load. The control current from the dynamometer is wired into the back of the dynamometer, the dyno plus and dyno minus connections. We recommend mounting the dump load high up on the wall, out of reach of anything that can burn. Also, make sure that the wires are of heavy enough gauge to carry the required current, and there's nothing flammable in the region around the heater. The speed pickup mounted at the bottom of the shaft and the load cell mounted below the dynamometer are wired into the back of the dynamometer controller. Speed is wired into RPM 1 and the load cell is wired into the labeled load cell. In some cases we have an external transformer. The external transformer is wired into the external transformer connection, which simply wires into the output of the transformer box. To start, we recommend switching to manual mode, setting the set point to 0 load, and turning the dynamometer current on. The engine's fuel flow has to be turned on. Gasoline engines should be choked halfway, and the throttle lever should be opened slightly. In some engines, there'll be an ignition switch, which needs to be turned to the on position, and then you simply pull the starter. This is the computer's data display from the dyno controller. We're going to apply a load to it now and increase the throttle. We'll do a throttle torque curve. We do this by going to the controller, switching it into speed control mode, and giving it a speed of, in this case, we'll start at, say, 3,000 RPM. Our speed set point is now 3,000 RPM, and the actual speed is 1,500. I need to open the throttle of the engine before it will apply the load. I slowly decrease the speed set point, you can see that the torque curve is being traced out over here, all the while we're recording the data. Eventually, at some point, the engine will stall. Our speed set point is now 1,000 RPM, and it's slowly loading the dyno. The engine RPM is 1,300 and going down. You see the torque curve is starting to drop off. Some systems come equipped with a digital fuel scale. It's basically a digital scale where you weigh the weight of the fuel. In operation, we can read the continuous weight of the fuel over here and the 1 minute average fuel consumption. Taking this number divided by your power, you can calculate your brake-specific fuel consumption.